Hi everyone. So in today's lesson, we're going to be looking at structural isomerism. So this adds another type of classification onto what we've already learned through our naming and drawing molecules. So first, let's start though with drawing the compound with the molecular formula C4H8O. Take a minute and try this yourself. I'll do an example here. I'll draw both the full structural and skeletal formula for this. So let's see, we have 4 carbons. Going to throw an oxygen on there. Let's do a double bonded O in the middle here. So remember that would be a ketone. And then add in my hydrogens. So each carbon has 4 bonds. And then the skeletal structure for this. Double check. We do have 8 hydrogens. We have an oxygen. We have a carbon. So a bit of review. The name of this would be sorry, we can put the 2 in front, but let's call it butane 2 Oh, okay, so here's my compound, molecular formula C4H8O. Now, if anyone else has drawn one, can you come up with something different from this one? In fact, sure. Come up with a lot of different things. In fact, there are 20 different structures with the molecular formula C4H8O. Okay, this is where all of our naming that we've done becomes so important because we need to be able to distinguish each of these structures. All of these, you see, some have different functional groups, some have aldehydes, some have ketones, some are cyclic, some have alkenes, the double bonded carbon, some have alcohol groups. Okay, all of these would have different physical properties and different chemical properties. So it's an important that we are able to distinguish between each of these 20 that have the same molecular formula. Okay, so structural isomerism. What that is, structural isomers are compounds with the same molecular formula, but different arrangements of atoms. So like we just saw, so all of those had the same molecular formula, C4H8O, but all were different structures. Okay, simple example here is pentane and 2-methylbutane. So both 5 carbons and 12 hydrogens. But one we have our regular straight chain alkane, and the other one we have a branching group. Now, seemingly the chemical properties of these, they're quite similar, but the fact one has a branching group does mean it has different physical properties, which we're going to get into in the next lesson. So this is a structural isomerism. So again, the same atoms, but a different arrangement. Okay, we can break structural isomerism into as few different subclassifications. Okay, the first one is chain isomerism. So let's take hexane for example. So we have a 6-carbon chain. Okay, we have 3-methylpentane as one isomer of hexane. So by moving the carbon on the end there and putting it in the middle, we can also make 2,3-dimethylbutane. Again, same number of atoms, different structure. 2,2-dimethylbutane and 2-methylpentane. So in each of these cases, we're just moving around the carbon atoms and attaching them in different sections to make a different version of the hexane chain, so still 6 carbons. So these are chain isomers. Another type we have are position isomers. So here's 2 examples, butane 1-ol and butane 2-ol. In both of these cases, they both have 4 carbons with the alcohol functional group, but here the alcohol is on the first carbon in the chain, and here the alcohol is on the second carbon of the chain. So in positional isomerism, we have the same groups, but just in a different location. Okay, and the last type of isomers that we have are functional group isomers. In this case, if you look at our first one, we have propanoic acid, so 3 carbons with a carboxylic acid group. Okay, and then the second one, an isomer of this, is methyl ethanoate. So here we have the ester functional group compared to the carboxylic acid functional group. So a functional group isomer is when the functional group actually changes by changing the position of the atoms. Okay, so again, all of these 3, chain isomer, positional isomer, and functional group isomers, are all subclassifications of structural isomers. For your purpose, you can just call them all structural isomers. Okay, so just a quick review of some things last time. So here's two. Again, we're looking at the C4H8O empirical formula, has the same molecular formula. Here's two different isomers that we can draw the full structural formula. So this is where we show every single bond of the atom. Okay, we have the condensed structural formula. Note with these, you can put in the double and triple bonds to help distinguish the position. It makes it a little easier if you draw them in. So we can see in the first one, we have our double carbon bond first, then two carbons in a chain, and then our alcohol at the end, so our OH. In the second one, we put the methyl group here in brackets because it's branching off of the main chain. So anytime something's coming off of the main chain, you can use brackets to signify that. Then our CH2 and our OH. And lastly, we have the skeletal formula. This one is personally my favorite. It's the easiest and fastest to draw. But it is not required for you to use this one. You can always use the full structural formula if you want, but you can use the skeletal, and I would recommend learning it because as you further your studies in organic chemistry, this will become more and more common. So again, everything we looked at here are just the different types of isomers. Okay, we have our different types of structural isomers, I should say. And then just a quick review of the different ways to draw molecules.